Good evening, participants. Am I audible? Is my screen visible? Good evening, dear participants. Can you please confirm? Am I audible? Is my screen visible? Yes, good evening. Thank you. Thanks for the confirmation. So today is day 8 of this Naan Mudhalvan Virtual Internship, Data Science, and we are in day 8. Okay, I welcome you all on behalf of Pantech elearning. So till now what all we have seen about the data analytics and exploratory data analysis. Okay, and then in yesterday's class we have started with the machine learning introduction, the types, and then what is the workflow of data science. The first step will be data collection, and I told you where all you can find some common data sets. Okay, so once we get that data set, we have to give it to the machine learning model. So before giving it to the model, we have to do some processing, and there are certain steps there. So that is comes under pre-processing. And for pre-processing, we have seen about one library which is scikit-learn. So we are seeing about one by one tasks. So today also we are going to continue with that. So what is the thing we have seen in yesterday's class? What is the tool we have seen in pre-processing? Tell me guys in chat box what all things we have seen. So when we have gone into the pre-processing, once we load our data set, we have to do pre-processing. So using scikit-learn, we have learned one tool. So if your data set is having many numerical value and each of one is them in different scale, you have to scale them. So the scale consists of either standardization or normalization or robust scaler based on the data you are having, right? Okay, so today we are going to continue with that. Since we have completed the scaling part, okay, we are in machine learning, and we have completed the feature scaling. Okay, and today we are going to see about encoding, imputing null values with scikit-learn, and outlier detection and handling. So what you are going to do with outlier? Okay, these three things we will try to cover in today's class. And regarding assignment, please make sure you are submitting it either in LinkedIn or Facebook. Once you post it, please copy that link and update it in the Google form which is circulated in the previous class. Okay, so many of you guys have submitted, very good. Okay, so those who haven't submitted it, please try to do it by today. Okay, so today is day 8, right? So in 2 days, which means in day 10, I will be giving you another assignment based on what all things we are seeing now. Okay, from this day 6 to day 10. So that will be most probably including the pre-processing. Okay, so in tomorrow's class, we are going to see about feature selection and then train test split till the model. Okay, so we'll start with encoding. Can we start, guys? Can I get thumbs up? So what is your issue with the assignment? So if you can't submit the PDF, you can just take a screenshot of the outputs and attach it. Okay, or else if you have any issues with that also, you can save all the images in a Word file or as a PDF and then upload that document. It will be fine. Once you join the group, you can post it in the group. Okay, once you go into that group, there will be option for posting, but you have to give all the correct format and you have to give the request for submitting. So it will be approved by us. Once if you submit properly, it should contain image or any proof that you have completed the assignment. Okay, otherwise if it is empty with just your name, it won't be accepted, so it will be cancelled by us. Okay, so we'll start with encoding now. So what is encoding? So in machine learning models, it can only work with numerical values. Okay, you cannot give categorical values into machine learning model. So for that, what we have to do is we have to transform these categorical values. For example, categorical values may be like, for example, if you are having a gender column, so there will be representing like male and female, but you cannot directly give this to the machine learning model. What you have to do is you have to do encoding, which means converting the categorical features into numerical values. For example, you can give like for male you can give 0 and for female you can give 1. So you can replace all these things like that. So this text data can be converted into numerical format. okay, and then you can do the further processing. So this is known as encoding. So if you are having any text data in your data set, you have to go with numerical values, okay. So that's what we are doing, encoding. So this process is known as feature encoding. And there are two types of encoding. The first type is nominal encoding and the second type is ordinal encoding. So we'll understand what the difference between these two. So in nominal encoding, it represents the data without any order or hierarchy. So for example, if you are giving male or female, or in other case, go with some other example. In iris dataset, the output column, the species we have seen, right? It contains 3 species. I think it is Setosa, Versicolor, Virginica. Or you take some other dataset with some other column names, okay? It has like 4 or 5 different features in that, repeating one, okay? And if you represent them without any order or hierarchy, like evenly, okay, not giving any order, then it will come under nominal encoding. So it can be done with one hot encoder, so which is going to give you a binary value 100010 like that. So we'll see that. And there is another thing known as ordinal encoding. So this assigns unique integer based on rank or order, okay. For example, if you are having the qualification, a column known as qualification, okay, and that qualification, it contains details like for example BSc, BE, PhD, MSc or MTech. So all these things are there. So you can assign some value, like for PhD it is the topmost, right? So you can give like 1 for it, okay, or highest value. From reverse case, if there are totally 4, you can give like 3, and then next one is 2, next 1, next 0. So you can encode them with numerical value based on rank or order or alphabetical order. So then it comes at a ordinal encoding, and it can be done with label encoder. So we have got two things, one is one hot encoder and one is label encoder. So these two are from sklearn. So we'll try how to use it. First, starting with the one hot encoder, what it is a nominal encoding. In nominal encoding, we are not using any order or hierarchy. So what will happen is, if I do this one hot encoding, see here in this column, color, I am having red, blue, green and blue. So it seems like blue is repeating 2 times, red is there, green is there. So this is the total color column. So if I want to encode this into numerical value, I can go with one hot encoding. So what we'll do is, it will do binary encoding with 1s and 0. So how it is going to perform is, see here it is creating 3 different new columns, okay. So it is giving like 1 0 0 0 1 0. So what is happening here? So it is creating a column in the unique features. For example, it is creating in red, blue and green, 3 columns. For red it is giving 1. So in the remaining places it is 0 because it is absent, okay. This is present, this is absent. And next this is blue. So it is going to give 0 for red, 1 in blue, and then green it is 0. So when you go for green, okay, red will be 0, blue will be 0, green will be 1. When you go for blue again, red will be 0, blue will be 1 and green will be 0. Okay. So do you understand, guys, what is happening behind this one hot encoding? So this is actually not giving any order or hierarchy. It is just doing the binary encoding by creating new columns. So to do this, we have to import this one hot encoder from sklearn. So from sklearn.preprocessing, okay, import one hot encoder. So this O, H and E will be in caps, okay. So you have to create a class for it, object for it, and then with that you can fit and transform the values. So once you've done it, you can actually see the results. Can we try this, guys, one hot encoder? Can I get thumbs up in chat box? Is it clear till now what is happening in one hot encoder? Do you guys understand what is happening behind one hot encoder? Here 3 unique features are there, so 3 column is created. If 4 is present, some other color, orange is present, means it is going to give or create another column, okay. So now we'll try to do this in collab. So for this I'll use the iris dataset itself, import cborn as SNS, import pandas as PD, okay, iris equal to sns dot load underscore dataset. I'll pass this name iris, so it is going to give me the iris dataset. Iris dot head, iris dot, see here in the species column I'm just show you or explain you with how the encoding is working. Okay, species, okay, dot value underscore counts. Okay, Setosa 50, versicolor 50, virginica 50. So this is what is there. Okay, so now what I'm going to do, I'm going to encode these things. So so for that I'll just load y equal to iris dot species column. Okay, and from sklearn dot pre-processing import one hot encoder. Okay, so encoder equal to one hot encoder. I'll tell you what this fit and transform is doing. Wait. So once you go into this one, so you have to fit and transform it. So encoded value, encoder underscore value equal to encoder dot fit. Okay, so there is two parts separately. Okay, one is fit. There is option for fit also. See here, fit is available, transform is available. It will come. Wait. Okay, transform is also available. See here, and fit underscore transform is also available. So what is happening here? So this is a class. Okay, one hot encoder. I am creating an object for it, and inside this there is some parameter known as fit or transform or fit underscore transform. You can do fitting separately, transform separately, or with one command using fit underscore transform, you can do it both of the process in same line. So fitting is like the training or processing. So it had to analyze, right? So when you pass this entire data, for example, if you are passing the species column, it has to find what all things present there, so what it have to do. Okay, so it will fit. You can fit it separately. So if you fit it, then you can go for transform, or you can directly go fit underscore transform. So in transforming, what will happen? So what is the task you are doing here? You are encoding it, right? So it will do the value and give you the output. That's what the transform will do. So in fit underscore transform, it will analyze and give you the output. Okay. And in encoder dot fit underscore transform, I am passing this y. Okay, and let me convert this to array, to underscore array. Encoded underscore value. We'll try to see what is happening here. Okay, we got an error, so this should be passed as a 2D. So I'll convert this into a 2D single column alone. Now this should work fine. Okay, sorry, it's 2 array, not 2 underscore array. Okay, fine. See here, so we got array which is consist of 1 0 0, and then when you go below it is 0 1 0, and then finally it is 0 0 1. So what is happening here? I am converting them to array so that I can see it. Okay, so we can convert this into a data frame also. So encoded value equal to pd dot data frame. So I can pass this encoded underscore value, comma. So I want to create a columns, so I'll set the columns equal to, I want to pass a list with column names is nothing but, so here there are 3 species, right? So for that we have created 3 columns. So in that sense, okay, first is Setosa, versicolor, virginica. Okay, so if I run this, so now a data frame is created, encoded underscore value dot head, for example. Okay, so now we have created a data frame using one hot encoding, which is nothing but if Setosa is present in this index, it is 1 0 0. When Virginica is present at last, it is 001. Okay, as I shown you with colors, right, in example, that's what happened here. You can also go with dot. Okay, you can print it directly. You understood, right, what is happening? 100, if it is versicolor, it will be inside of it 010 and 001. Okay, this is what one hot encoder is. So next, going to label encoder. So we'll understand how this label encoding works. So label encoding is nothing but an ordinal encoding method. It can be done with label encoder. It will assign unique integer based on rank or order. So it is not 00, it is 0.0. Can you see it? It is 1.0. 100, 010, it is giving it in binary. When you go for ordinal encoding, you see label encoder. What it will do is, see here, in this team we are having AA, BB, BB and CC. So it want to assign them unique integers for them. For example, for A it is giving them 0, and for B it is giving them 1, and for C it is giving them 2. So it is just converting into integers, okay? Converting the features into integers. So to do that, you have to import it from sklearn.preprocessing, import label encoder, okay, encoder.fit underscore transform. You can pass these data points, it will going to convert them and give you the output. We'll try to do it from sklearn.preprocessing, import label encoder. Encoder equal to label encoder. Okay, so what I am going to do is here, see here, in iris dataset I am calling the species column. So I am going to assign some value here. So what it will be, using encoder dot fit underscore transform. So I am fitting, transforming and storing it in this column itself. Okay, so what I am going to transform here, I am going to transform this species. Okay, so now if I go and visualize iris.head, since it is label encoding, it is going to give me, see here, the species now changed into 0. So what is happening here? We'll try to find iris.species dot value underscore counts. Okay, see here, it is 50 times 0 is there, 50 times 1 is there, 50 times 2 is there. Okay, we have seen it, right? The citrus has given 0, versicolor has given 1, virginica has given 2. So you can go and check the tail, iris.tail. So now we have encoded it into numerical format. Categorical features are converted into numerical features. Okay, is it clear about encoding? Can we go with imputing a missing value? We have completed the encoding. Do you guys have any doubt? Can we move on with imputing the missing value, which will be like, how are you going to impute the values? Can I get a thumbs up, guys? So in Pandas itself, we know how to find the missing value, right? Using isNull.sum, we can check whether null value is present or not. And if null value is present, you know how to handle it, right? So you can either drop it using drop NA, or you can like impute the value using fill NA. And in fill NA, you can pass some random value, or you can pass mean of it, or median, or mode. So we know that. Now there are some other options also for you to do this imputing with the help of scikit-learn. So how are we going to do that? So starting with, the missing values are common in a real world data set. Since you are collecting it outside, it may or may not be correct. And missing values can occur in data set due to variety of reasons, and it is important to handle because it can lead to misleading result. You cannot leave it empty. So for that, so you can do imputing. Okay. So with sklearn, there are three options for you. One is simple imputer. Second one is KNN Imputer. The third one is iterative imputer. So what is these three and what are the difference? Can we start, guys, with simple imputer? So a simple imputer follows a univariate approach. So what is this univariate? When I go for next things, it will be multivariate. See here. So univariate is something like it is based on one single column, or example you can give it as a series. Okay. Simple imputer follows a univariate approach to impute missing values because it is going to consider that single column, and based on the values in that column it is going to fill the null value. For example, what this will do is, with the simple imputer you can do like replace a null value with mean value or median value or mode value. So these three things only you can do. So but how it is doing? It is taking only that column. For example, I'll go and load the Titanic data set. We have given it in assignment, right? Copy path. Okay, so pd.read underscore csv Titanic.head. Okay, so I want to check for null value, which is nothing but Titanic.isNull.sum, right? So to check for null value, and it seems like in this age column there are 177 null values present. Okay, so consider this age column. So if I am going with simple imputer, I am going to consider this single column alone, only univariate. So what I will be doing, I will take this column and take the mean value and replace it, or take the median value and replace it. So it is based on this single column alone. So it is nothing but univariate approach. Okay, so it will consider that column and do these things. So you can do this mean median replacement with Pandas also, with finalyearning, or with simple imputer from sklearn.impute. So this is from sklearn.impute, import simple imputer. So you have to create an object for it, imputer equal to simple imputer. So in this, if you want to go for mean or median or mode, you have to mention it inside the strategy. So strategy will define if it's mean, it is going to fit and transform and replace the null values with mean value. If you want to go with median, you can mention median, or if it is mode, you have to mention as most frequent. Okay, so this will fit the data and transform the data. Okay, so now what we are going to do is, we have to see what is happening behind, right? So what I am doing is, see here I am checking isNull.sum and I got this in age column there are 177 null value. So I am going to locate it. Okay, in Titanic age column dot isNull. So if I run this, it is going to give me, and what will happen if without sum, it is going to give me true or false, which I can use it as a filter. So I can pass it like Titanic. If I pass it as a filter to my data set, I can get only the columns which are having null value in that age. Okay, so it seems like these are all the 177 null values in age column. See here NAN. So what I am going to do is, I'll create another data set, okay, with this null equal to, I'll store it here. So this will be useful for us for our later reference, where all null value is present. We can see, right, we can check for checking. I'm creating and storing it. So if I run this null, I'll get all these 177 null value in age column. So I'm going to first use the simple imputer. So from sklearn.impute import simple imputer. So imputer equal to simple imputer, and I want to mention which one? Strategy, right? The strategy, I'll set this to mean. Okay, so now in Titanic I can call the age column. See here I'm calling the age column, and I'm going to use the simple imputer dot fit underscore transform. Okay, and in this the Titanic column age. Okay, Titanic age column. So I'll run this. Okay, we got an issue, so I want to pass it as a 2D here. Now it will be fine. Okay, it ran. So now what I'm going to do is, I'll go with Titanic.head. Now we have filled the null value in age column, right? So we have to check in age it is fine since there is no null values here already. So I can go and check with Titanic.isNull.sum. The age don't have null value. Okay, so now the null values we already had, we are having it in this variable null, right? So I can take this index and check. So if I run null.index, it is going to give me these index. So these index which previously had null value. So I'm going to use it as a filter now. So in Titanic.locate, okay, what I'm going to locate? Null.index. So these are the previous null values I had in age. So 5, 17, 19, 26, 28. We have it here, right? 5, 17, 19, 26, 28, which had age or null value. So if I compare it now, see here, it is now replaced with the mean values. There is no null value. Okay? Or you can go with median or mode. So this is what a simple imputer will do. Clear? Clear about simple imputer? So next one will be KNN Impute. So this is new for us. If you have idea about machine learning algorithm previously, you know about KNN, which is K nearest neighbor, which is an algorithm. So it is used for machine learning prediction, but here they are using it for like replacing the null value by doing some algorithmic tasks or some statistics. So what is happening here? So this KNN Imputer, which is another multivariate imputation technique. Okay, it is a multivariate. Okay, it is based on many columns, so you have to pass multiple columns. So based on the relationship with other columns, the null value is filled here. Okay, so that's what will happen here. So what this will do, this KNN Imputer scans our data frame for K nearest observation to the row with missing value. It will then proceed to fill the missing value with the average of those nearest observation. So it is like what will happen, see here, if there is a null value, you can mention what is the neighbor point it should check. So based on the neighbor points which are near, okay, it will try to take the value and give you the value. Okay, based on the average values of the nearby points, it is going to impute. That's what this simply this KNN, K nearest neighbor. Based on the nearest neighbor, the number you are giving. For example, if you give as 3, here I have to give the number. So based on it, it will try to take what are the 3 nearest value, take that, take average of it, fill the value. Okay. Understand how this KNN imputer is working? So to do this, you have to go from sklearn.impute, import KNN imputer. So for this, you have to create an object and you have to mention as a parameter what is the neighbor value. And you can go with fit underscore transform. So this will replace the null values. Okay? Can we try it? Understood about how this KNN imputer is working? Can I get thumbs up, guys? So for this task, now there is no null value, right? So I want to reload my data set. I'll load it again since I want the null values to be present again. Titanic.isNull.sum. So now there will be again null value in the age column, okay? So what I'm going to do, I'm going to take some other column and I'm going to compare it with age. So based on all the other features, it is going to replace these 177 values. Okay. So for that, from sklearn.impute, import KNN imputer. Okay. Imputer equal to KNN imputer n underscore neighbor equal to, I'll set this to 3 now. Okay. So once I set this, I'll go and replace the columns. So what are columns I'm going to consider here is, this is a column, sibling and spouse here. So like this is like the relationship, they are having some names, right? So whether they are sibling and spouse, okay, or parent children, so all these things are there. So based on the age, these 3 columns I'm going to compare. So these don't have any null value. Based on these things, it is going to replace this value. So I'll pass this siblings parent, okay, parent children. So I want to pass the name correctly. Yeah, it's correct. And then the age. Okay, so I'm replacing them equal to imputer dot fit underscore transform. Okay, so I have to pass these things. So based on it, it is going to impute and give you the output. Okay, it ran. So now Titanic dot head. Okay, so age column is there. You can go and check with Titanic dot is null dot sum. So now the values will be replaced. There is no null values here. Okay, this is a method for imputation using KNN Impute. So there is final one which is known as iterative imputer. So this is like you cannot get it directly. Okay, so you can understand what I am telling when I actually run it. We will be getting error. So this is a developer option like that. Okay, not available for everyone. You can use it anyway. So iterative imputer is an example of multivariate approach. Okay, this is also a multivariate approach. So it models the missing values in a column by using the information from the other columns in the data set. So more specifically, it treats the column with missing value as a target variable, while the remaining columns are used as a predictor variable to predict the target variables. This is also like KNN, but this is different. And to use this, you can go with from sklearn.impute import iterative imputer. Okay, you can do the same task. For example, here, so I'll copy this once again. Okay, so instead of KNN imputer, so I have to go with iterative imputer here. Iterative imputer. Iterative imputer. We can fit and transform it. So this is also going to, so we have some, yeah, I told you, right? So this is an experimental option. So you have to do this line from sklearn.experimental, import this option. Okay, enable. Once you enable it, it will run. Okay, so now it ran, right? So Titanic dot is null dot sum. So this is how you can manipulate the values. Okay, there is no null value, right? So for cabin, you can compare it with some other column and give the value. So it is going to give those values. Okay, clear? So I can check the null index also. Those will be replaced now. Okay. You can round off it also and replace it. For example, like this. Dot round to 2 decimal points. Okay, now it won't happen because I have to reload the data set since there is no null values now, right? Okay. So that's it with imputation. Can we go for outlier detection methods and how to handle the outlier? Can I get thumbs up, guys? Is it clear till now? We have completed encoding and imputation. Next thing will be outlier detection and then outlier handling. Can we start? So starting with outliers. So outliers are data points that are significantly different from the other data points. So these are the observations that are unusually large or small compared to the rest of the data. So some different. Okay. So they are very far away from the main cluster of the data point. In yesterday's class, I told you, right, you are having age from 0 to 12. So instead of this final 12, if you are having 120, but the other things are from 0 to 11, but the final age is 120. So it is an outlier. It is a misleading data which may be some error. Okay. So in machine learning, outlier can have a significant impact on the accuracy of the model. So as they can bias the model's prediction and lead to overfitting, you have to deal with the outlier. First, if you want to check the outlier, how are you going to find the outlier? We already seen that using the IQR method, but there are some other options also. So when to use which one, we'll see that. So the outlier detection methods are like ZScore method is there, IQR method is there. Okay, another thing known as standard deviation method, it's similar to ZScore. Okay, you can do this main two things, ZScore and IQR method. So what are these things? Starting with ZScore method. So ZScore is nothing but, we have seen this somewhere, where it is. Remember guys, in yesterday's class we have seen this formula, where we have seen. Any idea? So we have seen it in standardization formula, right? So it is going to take the mean and deviation subtract it with the value and then divide by standard deviation, replace the value. So it is the same task here we are going to do, but what is the thing we are going to do here? So Z-score of a data point is a measure of how many standard deviation away from the mean data point. Okay. For example, if the Z-score is 2, which means the center value, for example, if it is 0, then the standard deviation, okay, standardly how it is deviated. So if it is 2, then the next point from 0 will be 2, and the next point from that will be 4. Okay, next point will be 6. Standardly deviation. So that's what the simple meaning of standard deviation is. So Z-score will give you how much it is deviated from the middle point. So the data point with the Z-score greater than a certain threshold is considered as outlier. So in this Z-score, you are getting a Z value, right? If it is greater than 3, that is a threshold value. If it is mostly 2.5, some will set to 2.5. So most commonly they will go with 3. So if it is up to 3, then it is not an outlier. If the value is above 3, then it is considered as an outlier. Okay. So if it is greater than 3, you have to consider those points as an outlier. So okay. So how to do this? So you have to create, this is the formula you can actually perform on your own. So there is no separate thing you have to do. So I'll create a function, see here, define outlier. So I am taking the input data. So this is a parameter, I want to pass argument the data set. Threshold I am setting it to 3. Okay, so I can set it 3 here, or I can pass the threshold here directly. First I am taking the mean value of this column, entire column I am giving. So np.mean, I am passing the data, so it will take the mean value here. Standard deviation I will get it here using std. So now I got the point individually here, mean value here, standard deviation here. To take the point one by one, I am going to use a for loop for I in data. So in my data, one by one the values will come. Okay, using Z-score equal to I minus mean by standard deviation. So this will give me this formula answer, right? Z. So I am checking whether the Z-score is greater than 3. Okay, so if it is greater than 3, I am going to print that as an outlier. Okay. So this is for common data point, you have to do this task. When you go with the data set, okay, you are passing the data, you want to find that entire column or row. So what I am going to do, I am going to just modify these things, but the base thing will be this one. Understood what is happening behind this function? We are taking the mean value, standard deviation, take the point one by one, calculate the Z-score as it is doing here. If it is greater than 3, print that as an outlier, otherwise leave it. Clear? So we'll start with this. Import numpy, we need numpy for this as np. Define outlier. I'll pass the data inside, and for this first I need to find the mean value. Mean equal to np.mean data and standard deviation equal to np.standard, and I'll pass the data inside, so we'll be getting the mean and standard deviation. Okay, now if I am passing a data set, okay, in the previous image I have shown you, right, the example. So it is for if you are passing it as a column or a single like list. So now if you are passing as a column entirely, so for I in range length of data, for example, if it's containing 177 row, I'll be passing 177 inside, so it will go and access one by one. Okay, and here Z-score I have to calculate, and this Z-score, it is an integer, I'm just doing it. Data dot iloc. Okay, so I value will come from 0 to the last index. Okay, that's what the length is. So I'll go with I. Okay, so this will give the value, so I have to subtract it with mean. Okay, and then divided by standard deviation. Okay, so now if I want to check, okay, I'll get the absolute value using np.absolute. In that I'll need the values. Okay, and it will be in a list, so I'll go and get the 0th index. So the actual value, if it is greater than 3, okay, I want to print, or I'll go with data.print iloc, the location of it, I value. Okay, so this is a function for doing it. Okay, so now we have to call the function outlier What column can we pass, guys? So I'll go with this numerical value fare, okay? So in the Titanic dataset there is a fare column, so I'll pass Titanic fare. Okay, so these are all the more deviated values based on the ZScore. Okay, if it is greater than 3, these are the values. Okay, so these are the columns, so you have to handle it. We'll see that how to handle it later. So now we have found with the help of ZScore. Is it clear regarding how we are doing it with ZScore? Just this formula, basic formula we are doing. Okay, so next one is IQR method. So this I have taught you earlier, so I will teach you once again a little bit deep. Okay, the IQR is calculated as a difference between the 75th and the 25th percentile of the data. So they calculate the IQR, which is the difference between the third quartile, which is nothing but the 75th, and the first quartile, which is nothing but the 25th. Okay, so the first quartile Q1 is the median of the lower half of the data set. Okay, if you split that, the 25th the median, and then 75th the median, it's Q3. So how to calculate them? The lower bound value will be Q1 minus 1.5 multiplied by IQR. Okay, and the upper bound will be Q3 plus 1.5 into IQR. So this will give you the lower and upper bound. So what you can do is you can use it as a filter. If the value is lower than the lower bound, you can consider it as a lower outlier. If the value is upper or higher than the upper bound, then you can consider it as a upper outlier. Okay, see here with this image you can understand there will be a median value. There will be like 75th Q3 and Q1. You want to multiply it with 1.5. Okay, if it is till this point, it will be like inside this. If it is greater than that, it will be considered as an outlier here and here, both the side. Okay, so going with the IQR formula, if you want to do it, what you can do is you can pass the data and get the quantile of 0.25 and 0.75, store it in Q1 and Q3. To calculate IQR, it is nothing but Q3 minus Q1, you will get a value. To calculate the lower bound, it is Q1 minus 1.5 multiplied by IQR, and the upper bound is Q3 plus 1.5 multiplied by IQR. Okay. Okay. So with that, we'll be passing it as a filter. If the data is lower than lower bound, or if it is greater than the upper bound, filter that and give me. That will be the outliers. Clear how this IQR is working? Is it clear regarding how this IQR is working? Can we try it? So I'll create a variable age equal to, in Titanic data set, I'll go and get the age. Okay, so the Q1 will be Q1 equal to Titanic dot quantile 0.25. So this is a Q1, and Q3 what it is? Q3 equal to Titanic dot quantile 0.75. So it's not actually Titanic, it's age. Okay, sorry, since we are storing it in a new variable, it's age dot quantile 75th. IQR will be Q3 minus Q1. Okay, you want to go and check with what are the numerical values. You have to check for outliers. You cannot know for a single column. Okay, or you can automate that. That will be complex. Now I am telling you how to do it for a single column. Okay, please listen. Now we got the IQR, so the lower value bound will be what it is? Q1 minus 1.5 multiplied by IQR, and the upper bound will be Q3 plus 1.5 multiplied by IQR. Okay, so I'll run this. So this will create some numerical values, so which I am going to use it as a filter now. Okay, in the age, okay, I am using it as a filter now. If the age, the values is less than the lower, or operator, age greater than upper, give me. Okay, so it is going to filter and give you that also, that alone. Okay, so we got some error, it is in and everywhere. Wait guys, I'll reload the dataset once. That may be an issue. Okay, it's actually some error here. This may be an issue. We'll check with this one. Age, if age is less than the lower value, or operator, age greater than the upper value. Okay, we got the outliers. So these are the outliers. Okay, see here, we got the outliers. So next step will be how to handle the outlier. Clear? And there is another thing also you have to understand. Which method should I use? If you go for ZScore or IQR, how will you decide which method you are going to use? Okay. So the ZScore method will work well for Gaussian distributed data. So someone have asked in previous class also, what is a Gaussian distributed or normal distributed? So if you plot the data, if it is like this, which is nothing but a bell-shaped curve, no skewed to the left or right. See here, it is towards the left, this is towards the right. So these are skewed data. The B here, this is a normal data, okay? So if it is in bell shape and equally splitted, a Gaussian data, for this data you can go with ZScore, okay? You have to plot, okay, using a histogram, or you can check it. And if it is a Gaussian distributed data, you can go with ZScore to find the outlier. If your data is negatively or positively skewed like this, you can go with IQR method. Okay, IQR method is better for skewed distribution and for large data with outlier, because Z-score is taking the mean and standard deviation. So outlier may like have an impact here, but when you go for IQR, you are taking the 75th and 25th percentile only, right? So it is not going to be affected by the outliers mostly. So that's the case. If you have outlier or it is skewed towards either end, you can go with IQR method. Or if it is normally distributed, you can go with Z-score method. Clear? And we'll see with outlier handling in tomorrow's class, okay? So please be patient. We'll see about outlier handling in tomorrow's class. And regarding this, how will you find? So I'll show you how to find it, okay? If it is normally distributed or what the case is. So in SNS.boxplot, I'll go with this age column. Okay, you can also go with SNS dot KDE plot. There is something known as KDE plot. It is going to give you the curve. Okay, so I'll pass this age here. See here, you got the plot, right? So with that, I'll upload another data set also. Water potability. Titanic.fare, we'll go and check with that. So if your assignment is pending, it will be accepted. Once you got accept, you can post it. Okay. You should have any proof for the assignment, whether it is a screenshot or any document file. If it is there, it will be accepted. If you don't post anything, just your name and details, it will be deleted. Okay. See here, it is skewed. Okay, in this case, what you have to do, you have to go with which data, which method to find the outlier. You can go with IQR. Okay, and see here, this is another data set. I'll plot it. Okay, water equal to pd.read underscore csv, and I want to take one column, use call. So this is a feature where you can take single column whichever you need. Okay, so there is something known as sulfate. So I'm going to take that alone. Okay, it's use columns. Okay, so SNS dot KDE plot. So here I'm going to pass this water. And see here, this is kind of equally distributed. This is a bell-shaped curve, you can understand. Okay, for this data, you can go with Z-score value for finding the outliers. And for these kind of data, you can go with what you have to go with for finding the outlier. It is the IQR value. Okay, and for handling the outliers, there are certain methods: trimming, capping, imputation. We'll see that in tomorrow's class. Okay, So that's it guys, thanks for watching. We'll see you in tomorrow's class. The assignment Google form link will be available in previous class. You can go and check that, okay? I hope the attendance link is working fine only, right? So that's the idea behind it. You won't be knowing whether that column has outliers or not. So if you want to first verify whether it is having outlier or not, you can go with scatter plot or box plot or KDE plot. Okay? Just imagine you are going with a box or scatter plot. So if you are going with a scatter plot and if you find some points which are like away from the like most common points, okay? So you can find like for the basic thing you can go with visualization purpose. With that you can find whether the outlier is present there or not. And if you are guessing like some outlier is kind of present, you can go and actually check and do some process for this. Regarding the process, we'll see in tomorrow's class. Sorry if there is any issue with the assignment or sorry attendance link, it will be sent as soon as possible again, okay, through mail or WhatsApp it will be given, so don't worry. Thank you guys, thanks for watching, we'll see you in tomorrow's class.